Good morning to all. Myself Shasna, and today we are going to learn about the fractions. So now let's start. So firstly, what is a fraction? So we can thought a fraction like a part of a whole. For example, let's suppose that if I have a pizza. So now if that pizza is divided into 6 equal parts. If that pizza is divided into 6 equal parts. So, if I want to tell about this part, so what word I can use? I can use 1 upon 6 or 1/6 of a pizza. So here, that's what a fraction is. Just a part of a whole. Something like this. So this slice of a pizza is just a part of a whole pizza. Now, what is the simple definition of a fraction? So we can thought of a fraction as a normal division problem written like this. For example, if I have a division problem, let's say 42 or not 43 divided by 2. So if I have this division problem, so I can represent that something like this, 43 upon 2. So this is a fraction, just a division problem written something like this. Now let's study about these fractions deeply. So firstly, today we are going to learn about the parts of the fraction, and then we are going to learn about the types of a fraction. So let's start. So firstly, let's start with the parts of a fraction. I think you know that very well. So basically, if I will have again 43 upon 2. So this 43, as you already know, the upper number is known as the numerator, and the below number, the number which is at the bottom, that is known as the denominator. Numerator and denominator. Now let's see the types of a fraction. What are the types of a fraction? Now, so firstly, the types of a fraction, let's study about that. They are very simple. Let's study about the like fractions and unlike fraction first. So what are the like fractions and unlike fraction? Let's study about the like fraction first. So if I will have two fractions, for example, let's say 2 upon 5 and 11 upon 27. Now, as you can see, these two, both of them, the denominators, let me have another pair of a fractions. Let's have 2 upon 5 and 3 upon 5. Okay, so can you see something very interesting about these two pairs? As you can see that in this pair, the denominators are different, but in this pair of fractions, the denominators are same. Here is the 5 and a 5, and here is 5 and 27. So that means, as I think you guessed that, this is the like fraction and this is the unlike fraction. What is a like and unlike fraction? Let me write down the definition of them also. So, like fraction. So the like fractions are the fractions which have the same which have the same denominator is known as the fractions with the same denominator which have the same denominator, they are known as the like fraction. Now, like this, the definition of the unlike fractions are the fraction which have the different denominators are the unlike fraction, the opposite of the like fraction, simple. Then we have the proper fraction and the improper fraction. I think you know that very well. So, let's study them also. Now, firstly, the proper fractions are the fraction in which the numerator is smaller than the denominator. For example, 2 upon 3, then 3 upon 5, 8 upon 9, 11 upon 27, 13 upon 58. So these all of them are the proper fraction as the numerator is smaller than the denominator. Now, these are the proper fractions. What about the improper fraction? Simply, the improper fractions are just the opposite of the proper fraction. That means, if we get improper fraction, they are the fractions with the numerator larger than the denominator. For example, let's have 11 upon 9. Then 5 upon 11. Sorry, this is basically a proper fraction. Then we can have 27 upon 11. 98 upon 15. Then let's have 97 upon 5. And at the last, let's have one more. 37 upon 11. So these all are the improper fraction. How can we say that? That's because the numerator is bigger than the denominator. So this is the proper fraction. This is the proper fraction. And this is the improper fraction. Now I think these proper fraction and improper fractions are also clear to you. Now, as we all know that the math could be represented by the 4 languages, with the help of the 4 languages: number, variables, diagrams and words. Now, let's see how to represent the fraction in these 4 different ways. But first, let's talk about the importance of a fraction. Do you think there is importance of a fraction? Okay, so do you know that you use these fractions in your day-to-day life without realizing it? Let's see. So when you have to tell the time in English, so you say that 12:30 or 2:30. Then there is one more example of telling the time, like 12 minutes, 12:45, 12 o'clock or 1. Now, there is a use of fractions in a time. Here is one more use of a fraction. So I think you use this word half many times. Yes, so this half is also a fraction. How it can be represented? It can be represented as 1 upon 2. And as we already know that the half is a part of a whole. So that can be represented. So here the half is equal to 1 upon 2. Now, let's suppose that you have to make something, for example, like a cake. So if you want to bake a cake, before that baking a cake, first what do you do? What do you do? Prepare the base of the cake. So for preparing the base, first you mix some eggs, and then let's say you mix some choco chips, and then the sugar and so on. So now, when you mix the egg, you are not going to mix whole eggs. That means you are not going to mix the 1 dozen of egg, as you already know that we get a dozen of egg from the market. So you are not going to use the all the eggs, 12 eggs. Are you going to use that? All the 12 eggs for just a 1 cake? Of course not. So you are going to use, let's say, 2 eggs or 1 egg. So that 2 egg is a part of the whole, right? The whole is 12. And we are taking the 2 part, which is just the 1/6. Let me tell you. So if we get whole, how many eggs are there in total? 12 eggs. And how many are you using? 2 of them. Now, as we all know that this fraction is just a division problem, so we can divide these. So, simply I think you are a smart kid. You can say that this is 1 upon 6. As 12 goes to 2 6 times, and 2 goes to 2 1 time, of course. Now, I think this is also clear. So there is, the fraction is very, very, very important. So let's see some more examples. Let's start representing the fraction in the numbers. So let's say that you have a pizza. Divided into 8 slices. Now there are 4 people. Simply, there are 4 peoples, and now you have to divide the pizza equally to all of them. So how are you going to divide that? So here is the importance of fraction. You need the fraction to divide the pizza to all the people. So let's see. So as you can see, how many slices are there? 8 slices. And how many people are there? 4 people. Just divide it. 8 divided by 4. What we are going to get? 2. That means each people is going to get 2 slices. So if someone will ask you that how many slices will each people get? So if we are going to say 2 slices, so what does that mean even? If some stranger has come and asked you that question, so what do you mean by 2 slices? It could be something like this. If a pizza is divided into 4 parts, so you can say these 2 slices and these 2 slices, so they have a great difference. So you can't use the word 2 slices. What you can use next? You can say that 2 upon 8, which means 2/8 of a pizza, which could be simplified and said as 1/4. Simple. Let's see. So how many slices are there in total? 6 slices. 8 slices basically. Sorry, 8 slices. Now, how many slices does each people get? 2 slices. So we get 2 upon 8, and as this is a division problem, let's divide it out, and what we are going to get? 1/4. 1 upon 4, which is 1/4. So that means each people is going to get 1/4 of a pizza. Interesting. Now, as we have studied about the like fractions, unlike fraction, proper fraction, improper fraction, let's see some more thing about these types of fraction. So I think that importance of a fraction is clear to you. Now what if I have to represent a fraction? For example, as we already learned that the math could be represented in the words, diagrams, variables, and of course in the numbers. So let's represent the fraction in all of them. Let's take 1 upon 2 and represent in all of these language. So 1 upon 2 in the words it could be represented as half. In the diagram it is going to represent, it will be represented like this. Take a circle or take any shape and then just divide it into 2 halves and then shed one part. So it can be also called as 1 upon 2, half of the circle or half of the whole. Then we get the variables. How can you represent the fraction in the variables? Very simple. You can represent that as x upon 2x. Then we have something else. What is this? What is this? Very familiar to you. Numbers. So how you are going to represent the fraction as a number? Very simple, 1 upon 2. So these are the 4 ways you can represent the fractions. Also there are so many ways, but these are the 4 of them. Some ways of representing the fraction. Now, as we all know that the diagrams, we can understand the diagrams more better. So we are going to use the diagrams for understanding the different fractions. So now let's use the diagrams. So we had talked about the proper fraction. It is very simple. Just if the numerator is smaller than the denominator. And if I want to represent, let's represent some of them by the help of the diagrams. So let's have 6 upon 8. Now, as you know that 6 upon 8, how we will represent that? Very simple. So we are going to divide a circle into 8 parts and then shed the 6 of them. Now can you see very interesting thing? This 6 upon 8 could be simplified as 3 upon 4. That's why, because 6 goes to 2 3 times and 8 goes to 2 4 times. So 3 upon 4, which is 3/4. 3/4. Now, so as you can see, we can represent it something like this. But what if we have improper fraction? Okay, so let's have any improper fraction. For example, very simple one. 11 upon 9. So how 11 upon 8? Let's take this one. So now how are you going to represent this fraction? A tricky fraction. Why is that? How can it be possible that 11 parts of a 9 part? What? 11 parts of a 9 part? If there is a pizza and it is divided into 9 parts, 9 slices, 8 slices, and as you already know, how can we take the 11 of them? If there is only 8 slices. Let's see. So this improper fraction is very simple. Let's have a look to this. So now if I have 2 pizzas, something like this, and as you all know that these 2 of them are divided into 8 parts. Now let's see very interesting thing. So if I am going to shade 8 of them here, all of them, and each pizza was divided into 8 parts. What is the fraction? 11 upon 8. Okay, so more simply you can write it as this whole, that is 1. And then what is the fraction here? 3 upon 8. So you can more simply, you can write it something like this. It is very interesting. As you can see, this is one whole. This number is a whole number, so it represents the one whole pizza, and this is the fractional part which represents 3 upon 8. So that means if I have a pizza, if I will divide it into 8 parts, and out of that 3 is represented something like this. So that means that 11 upon 8 is equal to 3 upon 8. Yes, it is. Now let's see what is this called. It is a something weird looking fraction, right? Because it carries a one whole number. So a fraction which has a whole number and a proper fraction together is known as a mixed fraction. The whole number part and the fractional part, these all are mixed, just something like this. So this is known as the mixed fraction. A fraction with a whole number and a proper fraction. Very simple. Now, do you know that we can convert the improper fraction to mixed fraction and mixed fraction to improper fraction? So let's see how can we convert these two. So it is very simple. Let's start knowing how to convert a mixed fraction to a improper fraction. So very simple it is. Let's have a look. 3 upon 8. So let's solve this also. This one. So simple thing is to just do like this. 8 into 1 and then plus 3. So that is going at this. So this is going to give you the improper fraction of this thing. Now if you will ask, why is that? Why is that? So that's because if we will take an improper fraction, something like this, 11 upon 8. So this is basically a division problem. So 11 upon 8 could be divided, right? How it will be divided? So 8 goes to 11 goes to 8 one time. Basically it doesn't come exactly, but we can take the nearby. So I think you know the division. Now, can you see something interesting in this also? In this? 1 here, 3 here and 8 here. That means one thing which you have to keep in your mind is that when there is an improper fraction or proper fraction, the dividend is at the upper side, at the top, and the divisor is at the bottom. And what happens in a mixed fraction is that the divisor is here, the quotient is here, and the remainder is here. So what you have to do is to get the dividend at the top. And as we already know the division rule, that DD or the dividend is going to equal to the divisor into quotient plus remainder. Very simple. So divisor into quotient like this, 8 into 1 plus remainder plus 3. Simple, very clear to you. So we have to get the dividend at the top. So that's why we do something like this and keep the divisor same. Now let's understand one more thing. I think now if we had understand this, how it works, so let's understand very interesting thing. We have learned about this, how to convert a mixed fraction to an improper fraction. How to convert, now here is the question, how to convert an improper fraction to a mixed fraction. Very simple, we have did it now. Just divide it. And what we are going to get? Something like this. And then just put it out. So if you are not able to remember that, where is the remainder, where is the quotient, just put an arrow like this. Very simple. And this arrow is going to make very simple. Just put it something like this. Okay, 1 first here, 3 here, 8 here. Very simple. So here, how can you remember this? Very simply, just put this arrow and write it. Now, I think the conversion between the improper fraction to the mixed fraction and the mixed fraction to the improper fraction is clear to you. And in my next video, we are going to solve so many questions about these conversion of the fraction. And do you know, in my next video, we are going to see the home of the fraction. Would you like to see the home of the fraction? Okay, so we are going to see that in our next video. So for now, let's end over here. Thank you for watching this video and have a cheerful day ahead. If you want any improvement in me, so you can comment it in the comment box. Thank you.